In this lesson we're going to look at the chain rule in more detail and look at some examples. So first example, if we want to differentiate y equals 4x minus 7 to the power 3, the first thing we want to do is we want to multiply down by the 3 and reduce it to a 2, keeping the bracket as it is. So like that. The next thing we want to do to finish off is we want to look at the bracket, this bit in here, and we want to multiply by the derivative of this. And if you differentiate 4x minus 7, 7 goes to 0 and you'll end up with just a 4. So multiply by 4. Finish this off by multiplying the 3 by the 4 to simplify it, and you get a 12. Moving on to the next example, more complicated one with a root 2x minus 1 in the bottom. We need this to look like this first form with a bracket and a power. So we should know that 2x minus 1 being square rooted is the same as this to the power of a half, keeping it in brackets. And also if we want to take this up to the top, we need to make it a power of negative a half. So we can rewrite that as 2x minus 1 to the power of negative a half. We haven't differentiated here, we've only rearranged it. Now we can differentiate this function, multiply down by the negative a half, write your bracket out again, reduce this by 1, so it goes to negative 3 over 2. We then have to multiply by the derivative of the bracket in here. So if you multiply by the derivative of this, then that's just 2. So multiplying this by 2 here, you're going to get a negative 1. But we've also got this as a negative power here, so I don't really want to leave it as a negative power, so I'm going to take this whole bracket down below the negative 1 and make it a positive power. That's going to look like this. And finally, I don't want to leave this at a point where I couldn't substitute a number in here if I needed to. So I'm going to change this bit here to a root and a power. Now the bottom number of the fraction is always the root, so this is the square root of 2x minus 1 cubed. And we can leave it like that. Okay, let's look at this example here. Y equals x squared minus 3x all to the power 4. So the same idea as before, multiply down by the 4, rewrite the bracket and reduce the power by 1. So this will go to this, but then we have to multiply by the derivative of the bracket here. So if you differentiate x squared, you get 2x. And if you differentiate this part, you've got to take away 3. So we need to multiply this by 2x minus 3. So you just set the brackets together. It doesn't really matter which way around you've got it. I've put the 2x minus 3 first and the cube at the end, just putting the powers in order. But you wouldn't be wrong to put it the other way around. Okay, and finally here, f of x equals cos cubed x. Now cos, this is really cos x all cubed in brackets, and it's easier to see this as this. So whenever you see this wee 3 in the middle, this is what it means. If there's a 2 in the middle, then it would be cos of x squared, and you'd put a 2 up here. If there's a 4 in the middle, you'd put cos x in brackets, and a 4 up here. You can put sine as well, obviously. So same as before, multiply down by the 3, reduce it by 1 to get a 2. So f dash x is 3 cos x and a wee 2, and then we have to multiply by the derivative of the bracket. So if we differentiate cos, then you get negative sine. So if we put all this together, really what you're getting is negative 3 cos x squared sine x. You could rearrange this and put the sine x first, and you could rewrite this with a wee 2 in the middle here, cos x and a wee 2 there. That would mean the same thing. And finally, just something to look out for. You've got to be careful with these two things. A lot of people think these are exactly the same. They are not. This one is saying sine x squared, and this is sine of x all squared. And we'll show you how to differentiate these two below. We've already looked at this idea. You rewrite it in brackets with a 2. So you take the 2 down in the front and you reduce it by 1, so you get a 2 and a sine x to the power 1, and then you multiply by the derivative of the bracket now. The derivative of sine is cos, so you get 2 sine x cos x. You could remove the brackets there to leave it as 2 sine x cos x. Now let's look at what happens here. Now really what you want to do here is we're thinking of what the sine of x squared is, so really the brackets would go there and there. Now that looks a bit clumsy, so I've rewritten it in the next line a bit better. So that's what you want to do, put your brackets round the x squared part. If there was a 2x there, you would do exactly the same, or a 5x, put the brackets round that part. So you want to differentiate the trig part, the sine part, and that's going to go to cos, and then you want to do the derivative of the bracket. So really what's happening here is you're differentiating the x squared, and you get 2x here, and then you're rewriting the derivative of sine x squared, which is cos x squared.